Alrighty, let's get started. Before I begin, I just want to say thank you for everyone who came to my talk. There's a lot of great sessions going on right now, and the fact that you picked mine really means a lot, so thank you. Today, we're going to be talking about how to extend Spinnaker with GitOps, and what is GitOps, and what does that mean? A little bit about myself. I'm Joel Vasallo. I'm the manager of Cloud DevOps at Redbox. This is my contact information. I've been in the Spinnaker community since late 2015 when Netflix open sourced Spinnaker, seen it kind of evolve over time. And even before that, a little interesting tidbit is I've been using Netflix's original release of their continuous delivery tool, Asgard, and kind of had the pleasures of using, 1.0 Spinnaker, which was pretty fun. I think the code is still open source, so if you want to take a look at it, it is pretty gnarly. So to kind of frame my topic, we have to kind of take a journey through modern CI/CD in 2018. How does this look? So first off, we got to start off with an environment, right? We have our code. We have code that we want to probably deploy to. So where do we want to put up our infrastructure? Do we want to be in the clouds, such as Amazon, Azure, Google Cloud? Do we want to stay on-prem? Hey, that's cool too. You can use things like OpenStack, Kubernetes, right? So at the end of the day, the solution, the answer is up to you. But just try and pick one, right, when you're getting started. You don't want to overwhelm yourself, so pick one. Cool. You got it? All right, let's go on to the next one. Source control. There's a lot of great source control options today. You want to use GitLab, GitHub, Bitbucket, Azure DevOps. A lot of great things in each of them. But at the end of the day, pick one. You have code that you want to write, and you got to store it somewhere. So pick one. We got it? Cool. All right. More options. So you have to do continuous integration, right? How do you build your code? Do you want to use GitLab? Do you want to use Travis, Jenkins, Drone? Where are you going to store that code? Where are you going to store those artifacts? Are you going to put them in Artifactory, Nexus? Maybe they're just Docker containers. All you need is a Docker registry. So at the end of the day, again, just pick one. I'm hoping you're keeping up with this. There's a lot of options as you're seeing. All right, and then finally, you have a place to store your code, you have a place to build your code, and now you need a way to deliver that code. So a lot of folks initially did custom Jenkins jobs. I've done that in the past. Deploy the data center, create some Jenkins jobs, SSH in, do it, great. But do a little bit of a spoiler alert, we're at the Spinnaker Summit, so we're going to probably talk about Spinnaker today. So, but pick one, right? That's the main thing out of here. So you picked a lot of things just now, right? Things are great now. You have all the latest and greatest tools, and everything's fine, right? Right? All right. Well, let's take a further step and see the potential good news out of this, right? So all these tools probably meant that your deployments are now trending upwards, right? Because now you have a way to repeatedly build your code, repeatedly deliver your code. Awesome. So since you're doing more deployments, probably productivity and development is probably trending upwards. You can release faster, and you have more time to implement changes, right? Awesome, great. Still not seeing a negative here. What's the whole point of this talk? You're probably having a lot of more releases now because you can release faster. You can have more, weekly releases if you like, or whatever you decide as a team. So where am I going with this? You're probably wondering. So in the previous slides, I gave over hundreds of different combinations you could combine. Whether you wanted to pick Azure DevOps and you wanted to deploy to Amazon and whatever, there's over 100 different combinations you could have selected, and they would have been unique to you and your business. There's not going to be one glue between that. So there you have a lack of reproducibility of tools and environments. What's the glue that's connecting all those tools that we were just talking about? You probably have manual CI jobs and continuous delivery pipelines. Traceability, right? How do you trace a change from source all the way to release? Basically the who, what, where, when, why, right? How did this change happen? Also, there's the lack of observability across all those environments. How are your systems running? Are they working? Are they in a desired state? Are they in an impacted state? Are things working optimally, right? And that's all kind of the things that we're going to be addressing in this topic today. And this is where GitOps comes into play. So simply put, what is GitOps? GitOps is the practice of leveraging Git as a single source of truth for your application's entire lifecycle. So this means code, build, config, and deploy. Great example, great words, but how can we visualize this? And yes, we can. So at its core, and very simply put, you have your source, some operator. We'll get into some examples of what this operator could be, and ultimately some target environment. It's an application stack, it's a Kubernetes cluster, it's a cloud environment, whatever, right? Something in source that's defined and very well defined, that has some operator listening to those changes to ultimately make some sort of an event, and a change, a creation, the deletion, a CRUD event, right? So what are some of the advantages of kind of following this GitOps model, right? You can build custom tooling, and that's common across your entire development platform. So by having common tooling, you can make it easier to onboard both operators and developers, because everyone is just using one tool. You're reducing that cognitive load between the various tools. Everything is in Git. Ultimately, at the end of the day, by creating custom tooling and common tooling, you could reduce potential errors through automation, right? That's the whole kind of principle of DevOps, is automating and through tooling. Some things that are also gained with this is you get traceable tooling. Git is a very great tool for tracking changes through its commit history, right? So you have better security through secure code reviews. And ultimately, that historical audit trail is always going to be a part of a Git repo, right? Which is great. And finally, you get observable tooling, because you get faster deployments and infrastructure changes through a custom tool, right? You get easier disaster detection and ultimate recovery. You have something to compare what you expect to be in your environment versus what you have defined. So this is the part of the talk where I have to kind of give you all a spoiler, is that GitOps is not new. It's quite common that we today version control, right? Your application source code and your runtime configuration. It's principles of 12-factor, right? You have you source control your configuration, and you somehow find a way to auto deploy it. Today, the common trend though is infrastructure as code, right? Through a lot of great tools. I like to argue that what about the build process of how your code is actually built, how your code is actually delivered, right? Is that factored into this whole source control model? Basically, at the end of the day, is you should have 3 goals in mind when you're writing tooling, especially through the GitOps model. At least from my perspective, is it should have reproducibility, traceability, and observability. So what does it mean to be reproducible? And this is a great question. So let's take a look at some well-defined examples, things that are industry standards, right? Docker files, and Jenkins files, Ansible, right? What makes these tools great is that they're well-defined. You can literally go line by line and understand what operation is going to happen, generally speaking, in serial fashion, right? You know that step 1, step 2, step 3. So if you can describe something, you can then automate it, right? If you know the steps that you need to follow, generally speaking, you can do things like how many workers nodes you need, what ports do you want to open on your container, how much resources should I allocate for this application, right? So now we can automate it. And the best part is if you have something that's well defined and you have it automated, you can use that to rebuild it, right? So where does this come into play is you can use this to enforce state. Another advantage of this is kind of alluded to with the exposed ports and resources is you can use this as disaster recovery. Imagine if you defined your entire infrastructure through whatever tool you may use. You can then reapply that state to a targeted environment and respin up your resources, assuming they got destroyed or something crazy, right? So that's what kind of reproducibility kind of comes into play out of the tooling here. Traceability. This is kind of just using Git for what it really does best. It's version controlling. Let's take a look at a pull request. It does a good job of capturing your diffs, capturing whatever changes, additions, right, to the repository, In addition, you have that open and public discussion, right? You could do a review and say, hey, I think this should be fixed. Hey, I think this should be removed. Why are we doing this? In some tools, you can say approvals. 3 people must approve before you can, merge into master, a conscious decision. And ultimately, you could track the changes, in this case, the merges to master, through the pull request tool, right? You'll be able to see like, hey, this got pulled in by blah. She approved it. He approved it. Whatever. You'll have that audit log as well. The best part about Git is you run into issues, revert it back. It's easy to revert back a pull request, right? Just roll back to whatever point in history you need. And when auditors come around and it's audit time, you can now describe how your tooling operates, but then also show your pull requests. You have a secure code review process. If you have a well-established code review, you can now trace changes to your environment. And finally, observability. GitOps, since we're using a Git repository to have a desired state, right, to track a desired state, you can use the GitOps practices to compare the desired state that's stored in your repository versus the actual state that's running. And any deviation from that, you can send alerts, send pages, do Slack messages, things of the sort. You can say, hey, I expected there to be 4 servers, but there's only 3. Something's going on. Is this a trend? Whatever. Again, this is not new. I mean, this concept of observability and having well-defined metrics is critical for things like your metrics and monitoring strategy as part of your application lifecycle, and ultimately can be used in your Canary and ACA, right, later on. A great quote around this is that the original DevOps concept was version control your config. We're extending that by version controlling everything. What can be described can be automated. It's a great quote by Alexis Richardson from Weaveworks. It's a really good. They're kind of pioneering this concept of GitOps. So a lot of great things came from that talk. So this is the part where I also had to do another bubble burst. Is that there's no GitOps tool out there on the market you can just buy, and you can check a box and say, "Yep, we have GitOps." And no, it is fundamentally it's not a single tool. It's a practice and ultimately a process. You have to kind of define this per organization, per project, what makes sense for it. You can't force a tool onto into an organization like this. In my opinion, the best way I've seen it successful is that you kind of consider empowering your developers. So it's a practice of empowering your developers to control their entire application through a very familiar workflow. And this is their Git repository. Steve got it right. Developers. Abstract away the tools and the implementation details. Developers don't want kubectl. They don't want to run Terraform apply. If they don't have to, they don't want to have to create their S3 buckets, right? They want a tool to do that for them. Make it as simple as submitting, reviewing, and hitting that merge request button. Bongo cat. So what do I mean by building tooling for your developers? By leveraging the concept of GitOps, you can empower the developers to make changes easily without getting buried in the details. I'm abstracting away some of those details. But important fact of this is that you don't want to eliminate the implementation details, not because that the developers can't understand the process, right? But rather they shouldn't need to. The developers are, in all purposes, paid to write code. They're not paid to maintain infrastructure. So your job as a DevOps, a SRE, whatever, is to provide tooling to make it simple for them to make changes to these systems, right? Kind of building on the concepts of no-ops. Give your developers full control of their entire application's lifecycle in a safe, simple, and easy way. Kelsey Hightower said it best, is as a developer, you probably have one flow in mind. Everything else is just noise. So I've done a lot of talking on the concepts of GitOps, and it's sometimes always helpful to kind of see examples. So to kind of refresh, how does this look? Again, you have your source control, your code, your configuration files, some event operator listening to changes to that source, and ultimately some artifacts being created. I do have to touch on some concepts of GitOps, is that some folks, and it's totally an acceptable practice, is separating out your application repo from your configuration repo and having maintained two. I personally lean to having everything in one because it kind of, again, eliminates context switches, but I can understand the value of splitting it out. I think this kind of drives the concept of no ops further and kind of makes silos, but find what works for you. They're both acceptable. So let's take a look at GitOps with infrastructure as code. Again, a lot of great tools out there. Just again, the goal of this is to pick one, right? Pick a tool that works for you and your business. For this example, we're going to start with Terraform. Not to bore you with the details, but what is Terraform? Terraform, you have a collection of HashiCorp syntax files that kind of look like this on the left. You run a Terraform plan, and it says, hey, you're going to create a security group. When you're ready to make changes, you run a command called Terraform apply, and it'll actually go ahead and implement your changes through the AWS CLI or whatever cloud provider you're aiming at, and ultimately write those changes to state. This is the part where your state gets actually modified, your declared state of your running system, if you will. So with this model, there are some challenges at scale. By default, I mentioned it earlier, but there's a local state file. The local state file is actually a file that lives on your laptop. This is when you're getting started. So with that, when you have multiple people working on one Terraform repository, you could have a very unsafe state drift. Susan has a state, and Joe has another state, and Sandra has another state. It can get very messy if you're not careful and have a solidified versioning strategy around your state. There could also be potential secrets in those files. So again, secrets on your local laptop, kind of a bad no-no. In short, as your team grows, running Terraform locally is really not an option anymore. It's not acceptable, and it's frankly dangerous, right? For many reasons. So instead, you should look at something like Terraform Enterprise, or ultimately build like a Terraform pipeline to handle these requests. So how can we apply the concepts of GitOps that we talked earlier to something like Terraform? Again, create a branch with the changes you want to propose, send an alert via chat that goes out to whatever chat tool you use, and you create a branch in a PR. And meanwhile, in the background, what's going on is a Jenkins job, very simply put, runs and does things like it tests the code to make sure there's it actually can work. The person who made the change is authorized to make this change. Enforce a style guide, right? Some basic things that in your day-to-day you'll probably do anyways, right? Automatically send out a result of that plan, right? So folks can immediately see this. So now the operator kind of goes into the repository and actually looks at the code and says, great, let's go ahead and make this change, right? This is a great change, great addition. So how does that look? Again, basic concepts of Git. You now merge that feature branch back into master. By doing this, you can trigger a Slack alert, again, kind of having that observable, traceable notification going out. From there, you trigger another Jenkins job to do the Terraform apply. So this job is going to go and fetch a remote state from somewhere that's not your local laptop. You can use like a blob store of any other cloud providers to store your state securely. It'll pull it down. It'll also initiate a lock so other people can't initiate a change as well. It's only tied to one. Make the changes, push the state back into the remote, and release the lock. And now you kind of applied the concepts of GitOps to one of these tools, like for infrastructure as code. So another example is taking this now from the infrastructure side, the environment side, now up to the CI stack, right? Kind of going through the earlier talk, how we kind of had the 4 pillars, right? How does GitOps work with CI? Again, today, there's a lot of great tools on the market for continuous integration, but just pick one. So for this one, we're going to pick Jenkins because it's kind of the oldest tool, and it has the most plugins and kind of one of the easiest to kind of show and often understand. So let's take a look at the Jenkins UI, right? You go ahead and you create a Jenkins job, and you click the whatever options, and you hit OK, and then you're presented with a screen of a lot of potential changes and things you can manually tweak and fill in the blanks and set in passwords and set in URLs. This is great, right? Because you can pretty much do anything in a Jenkins job. That's the beauty of them. But do that again for the UI team. Oh wait! The backend team now needs a job too, right? I'm sorry. That vendor also needs one. Do it again. There has to be a better way. You're gonna run into some challenges at scale, right? You kind of already saw in this example. It's time consuming to manually create Jenkins jobs. It's easy to do it for 1 to 3 jobs, but as your organization grows, it can easily get into the hundreds, and then maintaining changes across those can be painful. It's going to be time consuming to go into each of those jobs and say, update your source control endpoint. Hey, we're no longer using GitHub, we're using GitLab, and we have to point to gitlab.com. So guess what? We're going to go to each job and migrate them over. That's going to drive you insane. And even worse, outside of the tedious part, say Jenkins gets blown away, your jobs aren't declared anywhere. They're gone. Your build history is gone. How you build your code is potentially gone. You haven't defined this anywhere. And guess what? When you make changes in the UI, they're not really observable. I guess as an admin, you can have some fancy plugins to do so, but you won't know what you did to fix that one job that you may have to apply to the other jobs. What broke? What change that you just did broke 100 jobs, right? You have no real way of tracking that. In short, your Jenkins jobs has just become the most unique, difficult to repeat part of your infrastructure where your changes are not visible and ultimately they're not portable. This is not safe. So let's kind of apply the practice of GitOps to Jenkins. And the way I have done this before in the past is using a tool called the JobDSL Plugin. The beauty of the JobDSL plugin on the right there is kind of the syntax, so you can see it, is that it's scriptable via Groovy. You have direct control of the Jenkins XML. Basically, if it's in the UI and it's a featured button, you can literally dive into the XML and make the changes, even if there's not a plugin in the JobDSL framework. You can create helper methods for common configurations. So things like your SCM triggers, your steps, if you kind of see there, you can kind of define your triggers, check every 15 minutes, steps, run these Maven commands, right? You can ultimately set up a consistent poll of a job DSL and have it applied. Imagine you have your Jenkins job defined in each of your application repos. You can then have some tool, or it could even be a Jenkins job, to check each repository and reapply how that job should look every day, at night, or something. Making sure that what you have defined your Jenkins job to be is ultimately what is in actual Jenkins. And something that we're going to touch on is using multiple DSLs within this one job DSL, and we'll touch on that. So JobDSL is a great tool. You can define your Jenkins job, but boy, can it be extensive. There are a lot of options, a lot of great things you could set, but a lot of things you're going to find is you don't want your developers to kind of have to be a DSL expert to create a Jenkins job, right? A lot of this is probably going to be very simple. The developer knows where their code's at. They're probably building their code for Java or Go or for Python or whatever it may be. And there are probably a lot of similarities across a lot of these jobs. So maybe we could even take this a step further. And for that, I have the solution of creating an external JobDSL wrapper library. Simplify your developer's workflow from that giant mess over to something like what we have on the right here. Abstract away the URLs to store your artifacts. Abstract away any weird credential hashes and encrypted secrets. Standardize things, right? Maybe the base job for creating a Java artifact, it uses Gradle and runs Gradle clean war, right? Maybe that's the easiest way to get started with your company, but ultimately allow your developers to kind of abstract away and say, hey, I want to add these extra flags. So if you kind of look here on the right side, you'll see there's your job, here's some of your standard triggers, but if you look, there's a Jenkins utility library that I'm importing, and I say add base options. This adds a few things like the mandatory Chuck Norris plugin, so we can have Chuck Norris when your job fails. I'm kidding. But you can have things that are forced onto every Jenkins job as part of it, so like security tooling, things like that. Add your Gradle steps, add Sonar Cube, things of that nature. So a lot of talking, but how does it actually look in practice? So the first thing you want to do is you want to store all your job DSLs in Git, and you through this you could put it in like a directory. I don't know, we called it Runway, where at the company I worked at, and it was called DSL.groovy. You could create a pre-receive hook in your Git server of choice to listen to changes to that file, and when a change is triggered and noticed, you can do some magic, or ultimately you could do what I said earlier and just have a consistent poll. You don't have to, do an active change on a pre-receive or something. But assuming we did have a pre-receive, some Python script will probably see the change, run some code, and trigger a job rebuilder, pull in the wrapper library, take what is defined in the repo, plus the wrapper library to ultimately create however many Jenkins jobs you defined, right? And now you have them all defined in the repository. The beauty of this job rebuilder is that it's auditable. You'll know who changed it, when it changed. You can provide safe defaults. So maybe you know that the enterprise artifact storage URL is this. These are the credentials to default this. Ultimately, you can give developers overrides, so maybe they don't want to run these 3 commands. And you can enforce requirements. Sorry, corporate security says that all code must go through Sonar Cube, and there's no ifs, ands, or buts around it. We can enforce that standard. So that was GitOps with CI. Now let's kind of get to why we're probably all here. GitOps with continuous delivery, and how does that look? Today, there's a lot of great tools again for continuous delivery. We have Jenkins itself, we have Spinnaker, we have Flux, but we're at the Spinnaker Summit, so we're going to talk Spinnaker. I didn't think that was too much of a shocker for everyone. Again, let's take a look at the beautiful, beautiful Spinnaker Pipeline UI. A lot of hard work, a lot of great things happen in this UI, a lot of options, a lot of things you could define. It's a really, really powerful UI. You could basically create anything that you need in terms of business logic here. But as we probably, some of you may know, pipelines and business process can get very, very complex. This is one of these very complex canary rollouts that has just these massive amount of steps that do massive amounts of work. And I don't know about you, but I don't want to create this by hand every time I need to do that. This looks very scary. A lot of things that could go wrong here. So again, you want to create one Spinnaker job. Great, let's do it for the UI team. Oh, we need a Spinnaker pipeline for the backend services. Can we create a Spinnaker pipeline for backend foo? Sure, let's do it again. Oh, well, you delivered the UI and you delivered the backend, but what about the edge? Can we create another Spinnaker pipeline for just one more, just one more? It's never going to be one more, by the way, as we all know, in working in IT and development and stuff, right? It's never just going to be one more. So before we could kind of talk about what is GitOps, or how can we apply GitOps, we have to kind of understand what is a Spinnaker pipeline really at the end of the day. A Spinnaker pipeline really, simply put, is a comprehensive and well-defined JSON. In fact, you could actually see this when you're creating your beautiful pipelines. You can actually go to the configure button at the top right in Spinnaker and see edit as JSON. And that is basically defining everything you just defined in those little dots as a JSON, which is awesome. A lot of great things that can be done with that information now, right? So a lot of folks saw that and took advantage of it. The Spinnaker community and the Spinnaker team is working on the concept of managed pipeline templates. The folks at GoGoAir created an open source tool and released it open source called Foremast. And also the great folks at Armory created a tool called Dingy for this concept as well, to kind of build around this JSON concept. So I'm a little biased. I'm also on the Foremast open source team. So I'm going to be sharing what Foremast is and how it looks, and how we can use that to kind of drive GitOps practices as well. So Foremast is an open source tool that eliminates the need to create pipelines in the UI. It's done through kind of piecing apart that JSON, and we'll touch on that. It enables the ability to reproduce and version your Spinnaker pipelines, because again, they're in Git. And it gives the ability to standardize pipelines with safe defaults. You can override application-specific needs with safe guardrails. You could say things like, in dev, no matter how hard you try, you can only have one server for cost cutting. In prod, you must have 3 servers for resiliency. Things like that you can kind of establish. A lot of great companies working on this tool. There's a link if you need to check it out, or find me after the talk, and I'll be more than happy to talk about it. So how does it work? You have a collection of base templates, kind of defined there. We'll kind of touch on the pipeline stages. If you look at a pipeline stages, there's a Jinja 2 file. It's kind of a templating language out there for if you use Python, you know what Jinja 2 is. If not, you should look at it. It's a really great tool. But basically, you define your stages. If there was a previous environment, do a judgment step. If the next step is to do an infrastructure setup step, then do a deployment step. If you have a scaling policy, do scaling. You want to tag, you want to do QE. So let's take a look at this judgment non-prod. What does that look like? And if you look at the JSON, it's basically just JSON, right? It's literally just the pipeline JSON from that UI that we had split off into a file. And then you kind of fill in the blanks with whatever environment, like the checkpoint prod or checkpoint data.app environment. Fill in that blank with actual data per step. So in your project, your actual code, you have your source control where your code goes. You have your DSL Groovy. Hey, remember that from earlier? But then you have your 3 Foremast specific files. And what are these files? You have an application stage, you have an application prod, and you have your pipeline.json. In your pipeline.json file, you have you define things like key value pairs, like I want to use a Fedora base image. I want to send a notification to this Slack channel. I want to deploy to these targeted environments. Here's the owner email, and here's how to set up Chaos Monkey, a great tool. You should go check out a talk by Steve Baskell tomorrow. It's going to be really great. So you're going to want to change, let's say, for example, change the Slack notification. I want to make it go to the pound deployments channel instead. So what we're going to do is go ahead and do a git commit, because that's what we do. We do git commits. That's going to trigger a pre-receive hook, which is going to see that the pipeline JSON file changed and trigger a Jenkins job and pull in those base templates. And it's going to say, hey, I'm going to have to run Foremast against these base templates, kind of fill in the blanks within that those templates, and actually go ahead and run it. The nice thing about this is, again, you have an audit trail. You have safe defaults. You can kind of override things in your base templates that the developers may have set. And then ultimately you have enforced requirements. Everyone must have a quality engineering step after every deployment. You must have a scaling policy. You must have blah, right? The command that you kind of run is prepare app pipeline. This is the first. This is the command to kind of create your Spinnaker pipeline. And it posts a Gate API at port 77. There's the API port documentation you should go look at via X509. So that's how you kind of create your Spinnaker pipelines. But another great piece of Foremast is its staged infrastructure changes. So if you look, there's another directory called infrastructure, and there's a bunch of other things in there. So like we have IAM and security groups and things like that. So if we look at the security group JSON file, it is literally just the JSON to kind of create a security group. What ingresses do you want? What region do you want? What credentials should I use to make this change? And then on the flip side, in the developer source repo, they're going to define the ingress rules. They're going to say, hey, I want 10.16/16 to reach me at port 443 over TCP. Again, very simply put, you're going to do a git commit. It's going to see there was a change to one of the Foremast files. It's going to pull in the base template. You're going to have all the auditability, the safe defaults, the overrides, and you're going to create the app pipeline so the next time that it runs, it's going to go ahead and make that change, right? Again, posting it to the Gate API. So by making that change, we didn't actually make a change to the security group, and I wanted to make that clear. Because before every deployment, we have an infrastructure setup step that kind of does that modification. You may not always want to open your firewall to your application if there's nothing there to listen to it. Maybe you need to do a deployment. You wrote a new microservice that listens on another port. Why expose port 443 or some other port before it needs to, right? Why increase your attack vector? So by doing this, you can kind of figure out where it makes sense to make infrastructure changes before your deployment. Foremast will run at the infrastructure setup step, pull in the source repository with all the files, and run a command called prepare infrastructure. And this will actually do the modifications to your firewall, your modifications to your load balancer, things of that nature. And again, this is just a Jenkins job that you could kind of define what fits for you. Maybe you want to do the applications of the security group immediately. But for us, when we were doing our pipeline, we wanted to have a little bit more auditability and control over that. So we wanted to have, at the end of every change or whatever, we wanted to tag back to the repository so we know when that change actually when that change occurred. So we tagged back when we did our infrastructure setup step, and you could see also you could tag back when we deployed a dev and things like that. By this, you extend that concept again of auditability. You can now look at tags and see when things actually change. When did these Spinnaker steps actually run? And you can now correlate Spinnaker events back into your pipeline execution, which is great and awesome because auditors love the fact that they can trace basically a commit all the way back to an actual event of something happening, which is fantastic when it came for PCI audit season. Foremast also has AWS Lambda support. It has AWS S3 pipeline support, so you can deploy artifacts to S3 and objects to S3. And there's also the concepts of auditability and traceability. For Spinnaker, we wanted to use Spinnaker for our PCI deployments and SOX deployments. But as you all probably know, in various industries, PCI and SOX has a lot of restrictions, which are great and should be enforced. I think in every deployment, they do some great concepts in them. But we wanted to maintain that fast, continuous deployment speed, but also kind of eliminate some of the bogged down meetings, right? So we passed PCI level 1 using Spinnaker by creating things like searchable records of every deployment, right? And creating UIs for that. Things like developers can't deploy to prod. The single developer can't deploy to prod and approve their own change, right? Have 2 people be part of a change cycle. Enable a separation of duties in the approval flow, right? So maybe only the manager of the team can implement changes by the folks on that team. And then ultimately, the pipeline is locked in the UI. Part of PCI, we had to enforce standards such as testing after every deployment, before deployment, to make sure that we had a testing strategy and secure code review strategy. By having people being able to go into the UI, they were able to delete like the quality step in the event of trying to push bad code. We didn't want that, so we removed that. And Spinnaker has a great way to lock the pipelines in the UI. So I touched on it, but 2 developers must approve a change. The committer and the approver can't be the same person, right? And because we're using Git as our source control and defining everything in Git, we can find that information, right? The manual judgment step and the auditing step, the person who clicks that button can't be the same person who made that change. And if you look at the UI, there's a checkpoint prod. After that checkpoint prod, that triggered for us, to simply put, was a Jenkins job that looked at the person who clicked that event and caused that event, and then looked at the Git commit and compared. And if it looked the same, error, break. Automated change requests. At the end of it, we wanted to follow our change request strategy. It was a great process to track changes. A lot of the business used it for key metrics. It was simply put, it wasn't that big of a deal. We created a change request before the deployment, and then at the end, we just sent another JSON payload to whatever API like ServiceNow, and it just auto-closed the ticket after a successful deployment, right? It was a no-brainer to implement that. Earlier I mentioned that we created an audit database. So you can actually leverage Echo as an event stream to kind of, if you listen to it, and create a small app around this and kind of create and parse out information from there and store the pipeline executions for future lookups. We've created like a small MySQL database and just dumped it in there. Obviously, we're not at Netflix scale, so I don't know how scalable that design is, but it was such a simple win that we just kind of defined it there, and then anyone can go into the UI and see the approver, who changed it, the git commit that made it, the timestamp that it happened, and the pipeline execution. And ultimately, we just gave full access to the auditors for this, and they could kind of tear apart any changes that ever happened through our system. So I just did a lot of talking, but in short, the beauty of Spinnaker is really in its flexibility. You can build and define your pipelines that make sense for your business. And really, at the end of the day, no matter how you use Spinnaker, we're still setting sail together. What I just presented probably isn't the coolest topic and thing you probably went to in this entire weekend. There's a lot of great talks, a lot of technically advanced talks, a lot of things of nitty gritty. But this model that I just demoed off here was able to support hundreds of thousands concurrent deployments a year using Spinnaker. And we still are users of Spinnaker in the community. Really define what works for you. Don't try to over-engineer the solution. Find what works for your business, right? That's the goal. That's why we're all here. Some key concepts to take away from this. If you leverage Git as your single source of truth and version control everything, you can describe and declare everything, and you can then automate everything. This is kind of the concept from that. GitOps, again, is not a single tool. I demoed 3 in this talk, but it's really a practice. See a way to source control and version control these configs and how to layer on your solution, right? There's a lot of tools I showed off early on, and I only picked 3 from there, but you kind of get the idea. Again, empower your developers by creating tooling that gives them safe ways to control the entire application lifecycle, right? Create those guardrails so they can't really go off. And when they need to go off those rails, we can have a discussion on how to extend their permissions and their usability. And then ultimately, find what works for best for you and your business, right? What I demoed may not work for you, but there are probably, I guarantee you, that you could take these concepts and apply them to your business. And by using Spinnaker, you're able to create great custom solutions out there. And with that, I just want to thank you so much for coming for my talk. Again, there's my contact information. Please, by all means, come to my website or come to talk to me after the session. I do have to mention I do work for Redbox, and we are hiring. I'm looking for some great engineers for the DevOps team here. So if anything that I talked about is interesting to you, please, by all means, talk to me after. And thank you so much. Again, there were so many great talks, and the fact that you came to mind really means a lot. So thank you, everybody, and hope you have a great rest of your Spinnaker Summit.